Okay, so we're going to do section 12.2, day 2. We're going to talk about arithmetic series. So we talked yesterday about sequences. We also mentioned series. What's the difference between a sequence and a series? Yeah, sequences are separated by commas. Series are separated by pluses. Technically, it can be minuses, but we want to think of it in terms of adding. So we're going to find the sum of these things. So we had a sequence, for example, yesterday that went 1, 4, 7, 10, 13, ... But if we want to look at a series, the commas get replaced with pluses. What does the ... imply? Keeps on going forever, right? And so what they're going to do is they're going to ask you to do something like find the sum of the first 10 terms. Now there's another way to word that, and that is to ask you to find the 10th partial sum of the series. Okay? Why partial sum? Well, what does the ... mean? Goes on forever, but we only want to find the sum of the first how many? 10. So we're only finding a sum of part of the series, not the whole series. The whole series, the sum will go to infinity, right? It'll get infinitely large, but we want the sum of the first 10 values. So it's the 10th partial sum. If we wanted the sum of the first 3 terms, then it would be the third partial sum. If we want the first partial sum, it's the sum of just the first term. So it's just the first term by itself. Now there are 2 different ways that we can do this. One way to do this is to actually write out the first 10 terms. So what I can do is I can do plus 16 plus 19 plus 22 plus 25 plus 28. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I can add those together. Okay? So that's going to be 40, 53, 55, 75, 85, 94, 104, 110, 123, 133, 140, 144, 145. The problem with that method, guys, is what if I ask you to find the 109th partial sum? Yeah. What about the 1090th partial sum? You're going to be here for the rest of your life trying to write those things out, let alone actually add them up. So do you see the potential problem there? So it turns out that there's a shortcut formula to help us do this. And this is actually the second of our 5 formulas we need to memorize in this chapter. So what I'm going to do is I'm going to move these guys up higher. Actually, I can just get rid of those guys now. No, that's okay. I'll move them up here. And then I'll put my plus ... back. So let's say we didn't figure those guys out. So the sum of the first n terms. So instead of having an a sub n formula, we have an s sub n formula, s standing for sum. The sum of the first n terms, that's the nth partial sum, is equal to the number of terms divided by 2 times the first term plus the last term. If n is the number of terms, then a sub n is whatever the last term is. So if we're trying to find the sum of the first 10 terms, that's 10 divided by 2 times the first term plus the 10th term. 10 divided by 2 is 5. What's the first term? 1. What's the 10th term? 28. That's 5 times 29, which, lo and behold, gives us 145. So do you guys see that it actually gave us the right answer? Now the problem is, if we're not going to write out the first 10 terms, how do we know what the 10th term is? So what happens if we don't have all these? How do we find it? we don't multiply it. It's part of it, but not the whole thing. So how do we find the 10th term? So how do we go about finding the value of a particular term number? What do we use? Okay, D is part of it, but it's not just D. What is that thing? What's the whole thing? Yeah, what is it? A sub n. Right, it's the equation we learned yesterday, guys. To find a particular term value, you need the rule for the nth term. So a sub n is equal to the first term plus the number of the term minus 1 times d. What's our d here? What are we adding every time? Distribute 1 plus 3n minus 3. So a sub n is equal to 3n minus 2. So what is a sub 10 now going to be equal to? Well, it's 3 times 10 minus 2. 30 minus 2 is 28. So that's how we can get our 28 if we didn't already know what it is. Does that make sense to everybody? And we can get our 145 that way. So if you don't know the last term, figure out the a sub n equation, just like we did last night, and then use it to find the last term. Questions about that? So now, how would we do this if we wanted to find the first 109 terms, or the 109th partial sum? Well, then what we would have done is we would have taken this and plugged 109 in. That's 327 minus 2 is 325. So this would have been this would have been the sum of the first 109 terms is 109 divided by 2 times the first term plus the last term, which in this case is the 109th term. So that's 109 divided by 2 times 326. Those cancel and give you 163. And so now if we do (109) times 163, we get 17,767. So if we wanted to find the sum of the first 109 terms of this, it ends up being 17,767. And so we don't have to work out all 109 terms, and we don't have to add up 109 different numbers. This formula takes care of that for us. Now, we're not going to go into how the formula works, but it's actually a very simple formula. Okay, questions about that one? So that's how you work these out if they give you the series. Now, sometimes they're going to give you a series, but it's going to be in a different notation. So we need to talk about sigma notation. Sigma looks like this. It's the Greek letter S, capital S. We saw this before when we talked about standard deviation, because I showed you the symbol for standard deviation is also sigma, but it's lowercase sigma instead of capital sigma. So it's a little circle with a tail on it, right? Or if you prefer, it's a circle with a baseball cap. All right. This is capital sigma, and it stands for summation. What does summation mean? Sum. What does sum mean? Add. So we use S, sigma, for summation. So it turns out that we can also write a series in this format. So let's say I equals 1 to 5 of 2 plus 7i. And they could ask you to find the sum of this. There are two different ways to do this. One is using a formula that we just learned. The other one is actually manually working this out. So let's manually work it out so that you understand what sigma notation is all about, and then we'll do it with the formula. What sigma notation says is that you have a start number and you have an end number. So you start with I is equal to 1. Now this doesn't have to be I, guys, and it doesn't stand for imaginary. It's just a variable. It could be J, it could be K, it could be N, it could be P, it could be X. It doesn't matter. It's just a variable. Right? It's whatever variable's over in here. Okay? So I is equal to 1 is our starting value. That means we plug a 1 in for I. 2 plus 7 is 9. Then what we do is we increase this to 2. So now we use I is equal to 2 and plug it in. So 2 plus 7 times 2 is what? What is it? 16. Then we increase again. I is equal to 3. 2 plus 7 times 3 is equal to what? Then we increase again. I equals 4. And then finally, I equals 5. That's our ending number. 2 plus 7 times 5 is what? Okay? So do you see the starting number is the first value we plug in for our variable, and we keep increasing by 1 until we finally plug the top number in as our last value. That's what the summation means. And again, summation really means plus, so we now add those answers together. So this is really 9 plus 16 plus 23 plus 30 plus 37. That's 67, 70, 90, 106, 115. That's how you work out sigma notation, summation notation manually. The problem is, guys, what if this was I equals 1 to 57? Are you going to want to do it that way? Or what if it was I equals 1 to 1,000? No. But here's the thing, guys. Notice, what kind of series is this? What is it? What do we call that? Arithmetic. What are we adding every time? Could we have figured that out by just looking at this thing? Yeah, it's the coefficient of I is 7, so D is 7. If the coefficient of I was negative 7, D would be negative 7. As long as it's an I and not an I squared or something, and as long as there are no other I's in the problem, that's going to be your D. But you could always work out the first few terms to figure that out as well. Okay. So since this is an arithmetic series, can't we also use this formula? So the question is, how many terms are we adding up? 5. Why? How do you know? Well, we can see that there are 5 terms because we worked them out, but what if we didn't work them all out? What if this wasn't there? A 5 on top. That's great, guys, but what if this was a 3 on the bottom? Would it still be 5? No. As long as it's a 1 on the bottom, then the number on top is going to be how many terms it is. But what if we had the summation of n equals, or sorry, of I equals 1, sorry, I equals 3 to 17. How many terms is that? 15. Why is it 15 terms? Well, here's the thing, guys. When we do 17 minus 3, that's how many steps we're taking, right? Like when we were going from the 6th term to the 15th term, that was 9 steps. So if we take 14 steps, how many actual terms did we step on? 15, because we started on the first one, right? Does that make sense? So what you have to do to figure out the number of terms is the ending number minus the starting number. That's how many steps you took, plus 1 so that you include the one that you started on, the term that you started on. Otherwise, you just found how many extra terms you got. You're not including the one that you started on. Does that make sense to everybody? So you have to add 1 back in. Why is this 5 terms? Because 5 minus 1 is 4, and then you add the first one back in. That's where 5 comes from. Okay. Just wanted to talk about that because that's a common mistake. So this is really the sum of the first 15 terms. That's going to be equal to 15 over 2 times the first term plus the 15th term. I'm sorry, plus the 5th term, excuse me. That was my other example, right? Sorry, we're doing 5 terms, not 15 terms. We're doing this one. So that's going to be 5 over 2 times, what's the first term? Well, you plug your start number in, which gives you what? 9. How do we get the 5th term? What do we do? Yeah, plug your ending number in. You're not necessarily plugging 5 in. You're plugging whatever your last number is in. Does that make sense? Because remember, if this was going from, let's say, 7 to 11, that would also be 5 terms. But we're not plugging in 5, we're plugging in 11, whatever that last number is. So this is the start number. This is the ending number, which gives us 37. You guys have to understand the difference between the 5th term and a term value of 5. Our 5th term is 37. Right? The term value is 37. How do we get 37? By plugging a value, this ending value, in for I, regardless of what that number is. Just because it's a 5 doesn't necessarily make it the 5th term. If this was 3 to 5, what term number would it have been? If this was 3 and this was 5, 5 would be what term number? The third one, right? 3, 4, 5. Okay, so don't get this counter confused with the term number. When is it the term number? When this is a 1 on the bottom. But if the bottom number is not a 1, then the top number is not the term number. Okay, it's just what you plug in to get that particular term value. Okay, so this gives us 5 over 2 times 46. Those cancel, and it gives you 23 times 5 is 115. Do you guys see it gave us the same answer? But this would basically be the same amount of work if I was doing a sub 50 and 50 divided by 2, the sum of the first 50 terms. We would just plug in the first number, we would plug in the last number to get these two values. So it's much, much shorter than having to write out all the terms and do it manually. Questions about that? Okay. The last thing we need to talk about is this. What if they give us the sum of I equals 1 to n of our 2 plus 7i, and they tell us this comes out equal to 570. We want to know the number of terms in the series. How many terms do we have to add up in this series to get 570 as a sum? Okay, this is an important skill because a lot of times we have to start from an answer and work our way back to the original information. It happens all the time in math and in science. Okay, how do we do this? Well, we use our formula. S sub n is equal to n over 2 times a1 plus an. We don't know what n is, though, do we? That's what we're trying to find. We do, however, know what the sum is. What is the sum going to add up to? 570. They gave that to us this time instead of asking us to find it. Equals n over 2 times a1. How do I find a1? Plug the first term in, right? So if I plug a 1 in, a1 is equal to 2 plus 7 times 1, which is 9. Plus a sub n. The problem is I can't solve this right now because we have how many variables? 2. We have n and we have a sub n. We don't know either one of them, do we? But here's the thing, guys. We know something else that we can put in place of this. What is a sub n really equal to? A sub You guys see that? We know that formula from yesterday. So what I'm going to do is I'm going to take this out, and I'm going to put this in its place. We know a sub 1 is really what? 9. We found it up here. We don't know the number of terms, but we do know D. How can we find D? I shouldn't say we know D. We can find D. Yeah, it's going to be the coefficient of I, or we can write the first couple of terms out and then see what we're adding, but we know already it's going to be the coefficient of I, which is going to be 7. So this then gives us 570 is equal to n over 2 times 18 plus 7n minus 7 when I distribute and add. So that's going to be 570 is equal to n over 2 times 11 plus 7n, or 7n plus 11. Can we now solve this for n? What do you think? Yeah, n's our only variable left we can solve for. Is everybody with me up to this point before I continue? So let me do this. Let me move this over a little bit to make some room. And I'm going to take this. I'm going to move it up here so we have some extra space. First thing I would do is I would multiply both sides by 2. Why? Get rid of the fraction. Will it always be a 2? Yeah, because the 2 is part of the formula. So it's always going to be a 2 on the bottom. It's never going to be another number down there. So this gives us 1140 is equal to, here the 2's cancel, and we get n times 11 plus 7n. Now we distribute, and we get 1140 equals 11n plus 7n squared. Notice we have n squareds and n's, so we're going to have to get it all onto one side so that we can try and do what with it? Factor it, or what else could we use if we wanted to? Quadratic formula. Now, when the numbers aren't so bad, I'm going to put this in the right order also. If the numbers aren't too bad, factoring it is great. If the numbers are ugly, what might be easier to use? Quadratic formula. Will you have to be careful because of the big numbers? Sure. But we know that n is going to need to come out to be a whole number. That means that square root part is going to be a perfect square. Right? I mean, you can't end up with 7.3 terms, right? You can't have a part of a term. You either have an 8th term or you don't have an 8th term. Right? Whatever comes after the 7th term has to be the 8th term. So it turns out that this is going to give us minus 12. Let me see, 12 goes into 1140. 95 times. So when you FOIL this out, it does work. Or if you use the quadratic formula, this gives us n equals negative 95 over 7. This gives us n equals 12. Can this possibly be the right answer? There's 2 reasons why it can't be the right answer. What's one reason? It's negative. How could you be adding up the first negative 7 terms? What does that even mean? Right? It's got to be a positive number. So because they're negative, it can't be right. Why else can't it be right? It's a fraction, right? You can't have, 13 and 13 and 4/7, right, of a term. Or 13 and 4/7 terms, I should say. So that gets thrown out. Is this a reasonable answer? Yeah, so that means that this number must be a 12. There must be 12 terms that we're adding up to get that total of 570. Does everybody see how that works? Now, there's going to be 3 problems on the homework like this. I know these are a little bit cumbersome, but this is an important concept, working backwards from an answer. And so I'm not going to give you a bunch of these on the quiz and the test. I'm going to give you 1 on the quiz and 1 on the test. I promise I won't give you more, but I promise I won't give you less either. There will be 1 on both. Everybody clear on that? So you have to make sure you learn how to do this kind of problem. Okay, so there's 3 on the homework to practice. There will be 1 on the quiz, but only 1. There will be 1 on the test, but only 1. Okay? I'm not going to make you do a whole bunch of them, but I do want you to show me that you know how this works. All right, questions about any of that? All right, let me give you the assignment then.